Okay, our first screencast for Unit 3, Lesson 4 sort of cut off at the end, so we're going to go back over pages 152 and 153. By the way, this is screencast number 3 for Unit 3, Lesson 4. All right, on page 152, how do chemical equations show the law of conservation of mass? Well, first of all, you need to know that the law of conservation of mass states that matter is neither created nor destroyed in ordinary physical and chemical changes. Okay? This law means that a chemical equation must show the same numbers and kinds of atoms on both sides of the arrow, because a chemical reaction is a normal chemical change, so we can't create or destroy anything. Everything has to be accounted for. You have to have, at the end of the chemical reaction, you have to have the same number and types of atoms as you started with. You don't have to have them arranged or bonded to the same things, but they all have to be there. Okay? You're going to use coefficients, big numbers in front, to balance an equation. You cannot change subscripts when you balance an equation. Okay? All right, if you will look at page 153, it says count the atoms of each element in the reactants and products in the unbalanced equation. All right, we're looking at page 153 on number 10. It says fill in the blanks below to balance the chemical equation and sketch the products and reactants to show that the number of each type of atoms is the same. Okay, first they show you the equation without it being balanced. They just show you, each reactant and each product, and they all have coefficients of 1, but it's not balanced, because if you look, you have 2 hydrogens and 2 oxygens on the reactant side, the way it's written, and you have 2 hydrogens and only 1 oxygen on the product side, and that can't happen. Because remember, according to the law of conservation of mass, you can't create or destroy anything. And the way that it's currently written on A is that one of the oxygen atoms magically disappears, and that cannot happen. So we need to figure out what ratio our products and reactants need to be in order for us to have the law of conservation of mass obeyed. Okay? And we notice that if we will do a ratio of 2 hydrogen molecules to every 1 oxygen molecule, and we get 2 water molecules as a result, that ratio and that set of coefficients will allow us to follow the law of conservation of mass. So if you'll notice, I drew down in the boxes, there are 2 molecules of hydrogen for a total of 4 atoms of hydrogen. There's 1 molecule of oxygen for a total of 2 atoms of oxygen. That's on the reactant side. On the product side, we have 2 water molecules. Okay? But if you'll notice, the red, those are oxygens, so I have a total of 2 oxygens on the product side still, and a total of 4 hydrogens on the product side also. Okay, 154 and 155 I'm just going to kind of gloss over, because these topics are not really covered in the essential TEKS that we have to do for 8th grade. They're nice to understand, but like I said, they are sort of extras. You still need to do these pages and answer the questions and include this vocabulary, but we're not going to talk a whole lot about it in class. Okay, so first of all, what happens to energy during chemical reactions? Well, first of all, let's hop over where it says energy is always conserved. We have another law that says the law of conservation of energy states that energy cannot be created or destroyed. Okay? However, energy can change form. Okay? What this means for chemical reactions is that the total amount of energy does not change. Okay? We have 2 basic things that go on with most chemical reactions. Either a chemical reaction has to absorb energy from the environment in order to happen, or a chemical reaction will release energy into the environment as a result of the chemical reaction. Okay, if energy has to be absorbed from the environment, that is an endothermic reaction. Okay, so I'm back on page 154. A chemical reaction that requires an input of energy is called an endothermic reaction. Okay, this may be something that you mix together and it starts to feel cold because actually it's sort of stealing heat energy from its surroundings. Or it may be a chemical reaction where you actually have to heat the reactants in order for the reactants to undergo the chemical reaction. On the other hand, we have exothermic reactions. and those are chemical reactions in which energy is released to the surroundings. A lot of times the energy that's released is in the form of heat, but not always. Okay, can be in the form of light, some other things. All right, look at page 155, and you'll notice that they give you another chemical reaction. This chemical reaction they've illustrated is balanced the way that they've illustrated it. There is one molecule of methane on the reactant side. That's the one that's blue and green. Okay, so the green is carbon and the blue are hydrogens. And it is reacting with 2 molecules of oxygen, which means there's a total of 4 atoms of oxygen. So when methane reacts with oxygen, what you get is carbon dioxide, which is the green and red molecule on the product side, and you get water. So you have 2 molecules of water. Okay, but if you'll notice, I have a total of 4 carbons on the reactant side, a total of 4 carbons on the product side. I have a total of 4, I'm sorry, I said carbons, a total of 4 hydrogens on the reactant side and 4 hydrogens on the product side. I have 1 carbon on the reactant side and 1 on the product side. And I have a total of 4 oxygens on the reactant side and 4 on the product side. Okay? All right, now we're going to go to the handwritten notes that I gave you a few days ago. Okay, now I'm starting with the notes that you received several days ago, and apparently I made a little bit of a boo-boo when I copied these, because this side over here is the side that we need to do first. So this is really page 1, and over here is page 2. I'm sorry, they're not in the proper order. Okay, so I'm going to go through this. 2 or more elements chemically combined form molecules or compounds. New compounds are formed as a result of chemical reactions. Chemical reactions could be described in sentence form, but that takes time and you'd have to use a lot of words. A quicker way to describe a chemical reaction is with a chemical equation. Okay, so it says consider the following chemical reaction. You have, this is propane, C3H8 plus oxygen, yields or produces carbon dioxide and water. I have a couple of coefficients over here, but right now the equation is not balanced, so we will do that in just a second. Okay, so take a moment and make sure that you have the blanks filled in on that first set of notes, and then we're going to move to the left-hand side. The compounds on the left are called reactants. Okay, so we're talking about the left-hand side of this equation, or pretty much any chemical equation. Okay, what are reactants? Reactants are the compounds or elements that we begin with in a chemical reaction. Okay, in this particular chemical equation, the reactants are C3H8, which is propane, and oxygen. Okay. The arrow in your chemical equation means yields or produces. Really, you need to think of the word yields, okay? The compounds on the right of the arrow are called products. What are products? Products are the substances that are produced or formed during the chemical reaction. Okay, I've filled in the notes for you, so take a minute and write all of this down in the blanks. The compounds on the left are called reactants. What are reactants? They are substances, either elements or compounds, that you begin a chemical reaction with. What are the reactants in this particular chemical equation? C3H8, which is propane, and O2, which is oxygen gas. The arrow in the chemical equation means yields or produces. The compounds on the right of the arrow are called products. What are products? They are substances, either elements or compounds, that are made in a chemical reaction. All right, so now we're going to do our practice page. I am looking at NH3 plus H2SO4 yields NH4 with a 2, SO4. In words, that is ammonia plus sulfuric acid produces ammonium sulfate. Okay? What are the products? The products are what are the substances made in the chemical reaction. Your products are ammonium sulfate, and that's only one product. What are the reactants? Ammonia and sulfuric acid. Down at the bottom, you have another chemical equation. AlBr3 plus MgOH2 produces AlOH3 plus MgBr2. All right, in words, that is aluminum bromide plus magnesium hydroxide produces aluminum hydroxide plus magnesium bromide. Okay? The reactants, again, those are the things that begin a chemical equation. That's going to be aluminum bromide and magnesium hydroxide. Your products are aluminum hydroxide and magnesium bromide. Okay, I've filled in the products and reactants for the first equation and the reactants and the products for the second equation. So now we're going to move and we're going to look at these two chemical equations in a little bit more detail, and we're going to count the atoms for the reactants and the products. And then we're going to see if we have to do anything to balance the chemical equations. Okay, if you notice, I have illustrated each of the compounds that are involved in this reaction. But right now, if you look carefully and you count, for instance, the nitrogens on each side, I have one nitrogen on the reactant side but two on the product side, so I'm going to have to fix that. I have 8 hydrogens on the product side but only 5 on the reactant side, so I have to fix that as well. The way that I do that, I can only add whole molecules, so I can add a whole molecule of this, or a whole molecule of this, or a whole molecule of this. Okay? It just so happens that the only thing I need to do is add a second one of these, and so that's what I'm going to do right now. Alright, I've marked between my reactants and products with a black dashed line. Let's look at the reactant side. I now have 1, 2 nitrogens on the reactant side. Go over to the product side, I have 1, 2 nitrogens. Okay. I have 1, 2, 3, 4, 5, 6, 7, 8 hydrogens on the reactant side. 1, 2, 3, 4, 5, 6, 7, 8 hydrogens on the product side. I have 1 sulfur on the reactant side, 1 sulfur on the product side. 4 oxygens on the reactant side, 4 oxygens on the product side. So now everything is accounted for. What that means is, in order for this chemical reaction to proceed, I have to have 2 ammonium atoms for every 1 sulfuric acid atom in order to produce my product. Okay? So I'm going to go up to the equation now and add the coefficient that I need. Okay, notice that I put a 2 here. I don't put a coefficient here because if it's not written, the coefficient, just like a subscript, the coefficient is understood that it's 1. Coefficient over here is understood to be 1 also. Alright, let's do the next one. I have aluminum bromide plus magnesium hydroxide producing aluminum hydroxide and magnesium bromide. I'm going to draw my molecules for you real quick. Alright, without coefficients, I have 1 molecule of each of the products and the reactants. But if you'll notice, some of the things are equal on both sides and some of them aren't. For instance, the bromine, you've got 3 on the reactant side but only 2 on the product side, so that's going to have to be fixed. Oh, on the aluminum, I need to draw another OH, so let me do that because that's not balanced either. Okay, so we're going to have to add coefficients, which means we're having to add entire molecules in order to fix this. So let me show you what I do. Okay, remember balancing chemical equations, you can only balance by adding whole entire molecules. And that's what I did. I had to add another atom of aluminum bromide, two more atoms of magnesium hydroxide, 1 more atom of aluminum hydroxide, and 2 more magnesium bromides. Okay, so that is a 2, 3, 2, 3 ratio. So let's put those coefficients at the top. Okay, notice in black that I've added the coefficients, and the equation now obeys the law of conservation of mass.